So, let's see. So Friday we were doing, we basically spent the whole time talking about the least common multiple, finding common denominators, which is what we need in order to add and subtract rational expressions. So now we need to actually do the adding and the subtracting of rational expressions. And hopefully you guys have had a chance to review P.3 and P.4 on polynomials and factoring polynomials, because that will be very handy, especially to build up a common denominator, and then we need to multiply things out, and then we have to simplify afterwards, which means factoring again. So the steps for adding and subtracting rational expressions: first, you need to factor the numerator and the denominator, and then simplify each rational expression. So sometimes they don't simplify at all. Sometimes they do, and if they do, that will be easier for you when you're building up the LCD, if you can start with something simpler than what you began with. So once you have everything factored and you've simplified if you can, then you need to find the least common denominator. So that was finding what the common denominator is based off of the least common multiple. Then you need to build each rational expression so that they have a common denominator. What that means is you're multiplying the top and the bottom by the top and the bottom of the fraction by whatever is missing. So whatever is in the common denominator that is not in your fraction, that's what you do to build it so that it has a common denominator. And then you add and subtract at that point. So when you're adding or subtracting, you always look at the tops of the fractions, the numerators, and then your denominator stays the same. Once you've combined them by doing the addition and subtraction, then you simplify it. Sometimes you have to factor again in order to simplify. And that's it. So we're going to go through examples here just to demonstrate how this works. Okay, so I am starting off with something where it already has a common denominator, because that will make it easier to see what's going on. So here I've got addition. We have 2x minus 1 over x plus 3 plus 1 minus x over x plus 3. So we have a common denominator already. So we don't have to change anything. We're skipping basically half the steps. So if we already have a common denominator, then we are already gone through steps 1 through 4, and all we need to do is steps 5 and 6. So we start by adding these. So we add the tops, and usually the way I do this is I combine them first before I start the adding. So I have 2x minus 1 plus 1 minus x. So I'm just combining these fractions together because you're adding the numerators, the denominator stays the same. Then on the numerator, the top of the fraction, you simplify. So for example, we have this minus 1 plus 1. That cancels out because minus 1 plus 1 is 0. And then I have 2x and a minus x. So 2 minus 1 is 1. So we're left with a 1x over x plus 3. Now you would try to simplify. When we simplify, we always do things as we simplify by canceling things out that are multiplied. If things are added, like I have x plus 3, I cannot cancel things out. So that x on the top and the x on the bottom, I can't cancel because I don't have x times 3, it's x plus 3. So those are considered grouped together. When you have things that are added, those are considered grouped together. You can only cancel out things that are grouped. So that x on the top cannot cancel with the x because it'd have to cancel with the whole x plus 3, and those don't match. So in this case, since we can't cancel anything out, this is our final answer. And you don't have to write the 1 in front of the x. You can just leave it as an x, and you could write it as x over x plus 3. So are there any questions on this first example here? Okay. So I started simple. The next example here I have is subtracting. And here we don't have a common denominator. So here we need to create a common denominator. So that's where we need to find the least common multiple out of the x plus 4 and the x minus 1. So our common denominator, if I, oops, the way I've been doing it is I've been writing my denominators kind of over each other and then lining it up. So our common denominator, we would have an x plus 4 and an x minus 1. Because we're creating something that's bigger, and you're just taking, okay, if there's an x plus 4 in one of the fractions, then I need to have that in my denominator because I can't remove it. I can only add to my denominator or create more things in the denominator. So our common denominator is going to be x plus 4 times x minus 1. Basically, both denominators are just going to be multiplied together. So this is where I need to build a fraction up so that I have this denominator. So when I look at the first fraction here, the denominator is x plus 4. In our common denominator, we need x plus 4 and x minus 1. So I don't have the x minus 1 part. So I need to create that in my denominator. And when we do this, we always do this by multiplying. So I need to multiply this by x minus 1. And whatever I do in the denominator, I also have to do in the numerator. So whatever you're multiplying has to be on the top and the bottom. Now the second fraction, we have x minus 1. And because those are subtracted or added, those are grouped together. We don't have an x plus 4 in the denominator of that fraction. So we need to add or create that by multiplying by x plus 4. If I can actually get this to draw. There we go. And because we did it in the denominator, we also have to do it in the numerator. So I also have x plus 4, and that is multiplied on the numerator. So I'm going to just rewrite these so you can see what this looks like. And if I have just a number, like on the first fraction I have x minus 1 times 3, I can put that 3 first. So my denominators right now, what I have so far, if I put it all in the same color so it looks a little neater. So this is what I have. I have 3 times x minus 1 over x minus 1, x plus 4. And then I have minus 6 times x plus 4 over x minus 1, x minus 4. So now I'm going to combine these together because now they have a common denominator. So I'm going to write these together, which means you're combining the tops of the fractions. So I have 3 times x minus 1 minus 6 times x plus 4. And then my denominator stays the same. So it's 3 times x minus 1 minus 6 times x plus 4 over x minus 1, x plus 4. Now, in order to simplify, I need to actually multiply everything out on the top, combine like terms, and then factor and simplify if I can from there. So on the top, we are going to distribute the 3 through the parentheses. So the 3 gets multiplied by x, and it gets multiplied by a -1 there. So 3 times x is 3x. 3 times a -1 is -3. Now the second part, I have a -6. So that minus, we're going to treat that as a -6. So -6 times x and -6 times 4. So a -6 times x is a -6x. And then you have a -6 times 4, so that's a -24. And then my denominator stays the same. Are there any questions so far? Okay. So the next step from here is to combine our like terms on the top of the fraction. So if I look at my x's, 3x and -6x, those can be combined. And that's 3 minus 6 when you're looking at that. That's 3x minus 6x. So I'm going to just move to the right here because I'm running out of vertical space. 3 minus 6 is -3, so that's minus 3x. Then we want to take a look at our -3 here and the -24. Those are like terms. So that is a -3 minus 24, so that's -27. And then I have x minus 1 times x plus 4. So now that we've actually simplified the top, now we want to see if we can cancel things out by factoring. So on the top of the fraction, we want to factor out the greatest common factor so that we can see if anything will eventually cancel out. So I have a -3x minus 27. If there's a negative in front, we always factor out a negative. And then out of 3 and 27, the biggest number I can divide out is a 3. So I can factor out a -3. So I put that -3 in front, and then I divide -3 out of each of those numbers. So a -3 divided by -3 is a 1, so I'm just left with an x. Then -27 divided by -3 is a +9. And then my denominator stays the same. Once you factor, then you look to see if there's anything you can cancel. If there's anything in parentheses that's the same on the top and the same on the bottom. In this case, we don't have anything in common because we don't have an x minus 1 or an x plus 4 on the top of the fraction, and we don't have an x plus 9 in the bottom. So we can't cancel anything. We can't simplify further. So that's when you're done. So that is your final answer. You have this -3 times x plus 9 over x minus 1 times x plus 4. So are there any questions? Clear as mud. Well, hopefully more examples will get more clear. It will, with more examples, I mean, at least you'll start getting into the pattern and seeing what's going on. Okay, so now my next example, I have 2 over x squared minus 9 plus 4 over x plus 3. So in this case, if you have anything that is squared in your denominator, that means you need to factor. And so it's not simplified, we need to factor. And we have to factor the x minus 9 part. So x squared minus 9, that factors to x plus 3, x minus 3. And that is p.4 when we're factoring. So that is a difference of 2 squares. And when it factors, basically what happens is the middle term is 0. So you need 2 numbers that multiply to -9 and add to 0. And that's how you get 3 and -3. So I'm going to now rewrite this. We have 2 over x plus 3, x minus 3, plus 4 over x plus 3. Now we need to look for a common denominator. So on the first fraction, our denominator has x plus 3, x minus 3. The second fraction has x plus 3. So our common denominator is going to have an x plus 3 and an x minus 3. Because I can't remove anything from a denominator, I can always only create and add more things to the denominator. And so the first denominator, I can't get rid of anything, but I can create an x minus 3 in addition to the x plus 3 in the second denominator. And I'll be doing that by multiplying. So we'll be multiplying that second fraction by x minus 3 so that those match. And then that means you're also doing that on the top of the fraction. So I end up with 2. The first fraction basically stays the same. So it's 2 over x plus 3, x minus 3. The second fraction, I need to get an x minus 3 in the denominator, so I'm multiplying. And so then I need to multiply the top and the bottom by x minus 3. So once I do that, I'm going to just rewrite these so that you can see what I have so far. And now we want to add these 2 fractions together because they have a common denominator. And so that means we're going to create one fraction. So I'm going to have 2 plus 4 times x minus 3. And then my denominator just stays unchanged. Now that I have 2 plus 4 times x minus 3, I need to simplify the top. I need to distribute my 4 through the parentheses. So I have to do 4 times x and then 4 times -3. So I have 2 plus, then 4 times x is 4x, and 4 times -3 is a -12. And then my denominator stays the same. So now I have 2 plus 4x minus 12 over x plus 3, x minus 3. Now you want to combine your like terms on the top because we need to simplify. So I can combine the 2 and the -12, 2 minus 12. And that 2 minus 12 is -10. And usually we put the x's first. So I'm going to put the 4x first. Actually, I'm not going to have enough room there. So I'm going to just move this over here. So I'm going to have 4x, and then 2 minus 12 is negative 10. And over x plus 3, x minus 3. Now that I've combined like terms, we need to try to see if we can cancel anything out. So I need to factor the top. And whenever you have, if you don't have an x squared, it's always going to be factoring in terms of like the greatest common factor. So I'm looking for the greatest common factor between 4 and negative 10. I'm looking for a number that I can divide into both of those. And I can divide 2 into 4 and 2 into negative 10. So that's going to be my greatest common factor. So I put that in front, and then I divide 2 out of the numbers. So 4 divided by 2 is 2. So now I have a 2x. And then negative 10 divided by 2 is negative 5. And then my denominator stays the same. And now I look to see if anything is the same on the top and the bottom that I can cancel out. What that means is I would have to have a 2x minus 5 in the bottom somewhere, or I would have to have an x plus 3 or an x minus 3 on the top. And I don't have any of those, so I can't simplify, and that is the answer. Do you guys have questions?
It's making a little more sense as we go.
Good. You may need to watch more videos after this as well, because I only have one more.
I feel like I've learned this before, and it was easier the first time I learned it, and it looks so familiar. But
that's exactly how I feel.
Yep.
It might have been easier just because you might have been more familiar with algebra at that time. Right. So yeah, if you've been a very long time, it's like, oh man, I think I remember this, and at one point it was easy.
Yeah, over 40 years ago.
Yeah.
Yeah, like funny for me, so I hear you.
Mm-hmm. Yeah, and what we're doing here, you need this for this week, obviously, on the homework, but you also need to be able to do this stuff in week 3 and in week 6. So I don't know if you want to write a little note to yourself that you're going to have to at least figure this out, or at least be able to kind of follow the steps and everything once you get to week 3 and week 6, because we're going to be needing these skills in those weeks.
Yeah.
I have a question.
Yes.
Can you skip this step and then go straight to where you wrote 2 plus 4 out the bracket x minus 3 all over x plus 3 x minus 3? Can you skip that 2 steps and go straight to that step?
Okay. First off, let me make sure that's an x minus 5, so I should make sure that looks like a 5. Which step are you at?
Where you use the green arrow for the example.
Okay. So, no. So you can't, where we distribute, you have to write the next step. You can't skip to the last step from there. Those are very important steps. There's no pattern that will allow you to go from the step with the green arrows to the last step. Okay. There's no pattern there. The only step that you could skip would be this step right here. That's okay. The only one that you would be able to skip, where I just rewrote it. All these other steps are necessary.
Okay. All right. Thank you very much.
You're welcome. Are there other questions? Why would you want to skip that step? the step that I have in yellow, you can skip it if you because you can just look at the step ahead of it. And all I did was rewrite the step ahead of it, and I just kind of, instead of writing it and demonstrating what I did, I just rewrote it. So the step ahead of it and the step below, the one with the red x minus 3 and then below, you can go to the next step where you combine it without writing that middle step, because you can still see the pattern in what you have. Other questions? Okay. So this is my last example. And if you need more examples from here, there are plenty of YouTube videos on the internet where they do examples. I'm sure there are probably thousands of examples, so you can probably watch as many videos as you want on these things. But I've just got one more here, and this is a 3-stepper, or a 3-fraction one. But the steps are essentially the same. So I have 2 over x plus 1 plus 2 over x minus 1 plus 1 over x squared minus 1. So I want to make sure all of these things that are added, think of those as having parentheses around them. So you cannot just say, oh, I've got x plus 1, x minus 1, let's combine those, and then I end up, the ones cancel. It doesn't work that way. Those have to be considered together. So I need to factor the x squared minus 1. Anytime you have something squared, you have to factor that. This is another difference of 2 squares. This factors to x plus 1, x minus 1. So I'm going to rewrite what I have. I have 2 over x plus 1 plus 2 over x minus 1 plus 1 over x plus 1, x minus 1. When we're looking for the common denominator here, we're looking at all 3 fractions. So my first fraction has a denominator of x plus 1. The second one has a denominator of x minus 1. The third one has x plus 1, x minus 1. So if you're looking at what your common denominator would be, you have to have an x plus 1, you have to have an x minus 1.
And that's it, right?
And that's it.
Okay, that made sense.
So the first fraction, I have x minus 1. I don't have the x minus 1. So I need to multiply that one by x minus 1. And I need to also do that on the top. The second fraction has x minus 1, but it doesn't have x plus 1. So I need to multiply that one by x plus 1 on the top and the bottom. And then the third fraction has our denominator, so we don't have to do anything to that third fraction. So now I'm going to rewrite these. So I have 2 times x minus 1. I'm just flipping that because we like to have the number in front. And then our denominator is x plus 1, x minus 1. The order that those are written doesn't matter. So it's the same as x minus 1, x plus 1. If they're multiplied, you can write them in different orders. Then I have plus 2 times x plus 1. So my denominator is x plus 1, x minus 1. Then plus 1 over x plus 1, x minus 1. So I'm just rewriting it, and then I'm just kind of flip-flopping some things so that everything is in the same order in the denominator. Now I want to combine all of these into one fraction. So I'm just going to combine all of the numerators together, and they're all added. So I can just put pluses in between. And now I have x plus 1, x minus 1. So now I need to simplify, so that means I need to multiply, I need to distribute. So I'm going to be multiplying the 2 times x and the 2 times negative 1. That gives me 2x, and then 2 times negative 1 is negative 2. Then I also have to multiply the second set, 2 times x, and this times 2 times a positive 1. So 2 times x is 2x, and 2 times 1 is 2, so I have plus 2. And then I have my plus 1. And then my denominator, I am not touching anything there. So now on the top, I have 2x minus 2 plus 2x plus 2 plus 1. And I would need to add like terms. So I have a 2x plus a 2x. Those can be combined. Oops, not the highlighter. I want the pen. 2x plus 2x is 4x. So I'm going to just write that over there. Then I want to add the numbers. So I have a negative 2 plus 2 plus 1. So negative 2 plus 2 is 0. So those cancel. So all I'm left with is plus 1. So I have plus 1. And then x plus 1 times x minus 1. So now I look to see if I can factor on the top. So on the top, if I don't have anything x squared, I need to look to see if I can divide any numbers out. But there is no number that I can divide out of 4 and 1 except for 1. And that's not going to do anything. So I can't factor anything on the top, which means I can't simplify anything either, because 4x plus 1 does not match x plus 1 or x minus 1. So those don't cancel. So that would be my final answer. Most of the time when you add or subtract with fractions, things don't really cancel in the end. Most of the time, once you're done, once you've added them, that's it, because they don't cancel. Sometimes they cancel, but it doesn't happen often. There are questions.
Oh, but these examples did actually help a lot.
Good. And I was trying to go as slow as possible on these. I didn't want to rush through it. Anything else? Any other questions or comments? Well, so that was the last example that I had, and I'm glad that I split this up into 2 sessions, because there was definitely no time. We would not have been able to finish all of this on Friday. So hopefully, I'm glad that this was helpful. And if you guys do need more examples, basically, if you just YouTube add or subtract rational expressions, basically like literally the name that I have on my PowerPoint, you should be able to come out with lots of examples. So any other questions? Anything? Any questions you have on things that are not what I just covered, but maybe about the class in general? Okay.
Yes, I do have one.
Okay.
Okay, for some reason, when I was doing the homework, it clicked. And then when I was looking back, I'm starting to click again.
Awesome.
But so when will that be graded, so I know if I need to really go through it again?
So everything is graded by, our due date for grading is Friday at midnight. So our grading days are Wednesdays, Thursdays, and Fridays. So depending on who your grader is, some graders are faster than others. But I can guarantee that by Saturday, everything will be graded. That way you can take a look at your feedback. And then that way you know what you need to study before the quiz, because our quiz next week will be on this week's material, because we want a chance for you to see your feedback before you quiz, you know.
Okay.
So by Saturday, you should be able to see all of your feedback. Some of the graders, what they will do is they'll leave the little comment boxes on the file itself. Some will leave you feedback in the feedback box when you open up your document. And some actually will attach a file and where they mark up your work, kind of like I do, like writing with pen and those kind of things, and then they'll include like a picture of it. So
you're saying next Saturday, even though I've already had mine turned in, it'll be next Saturday.
Yeah, yes. So not like yesterday, the next Saturday coming up. That's when you'll see it. Yes. Yeah, because we just have our grading day is always Wednesday, Thursday, Friday, and a lot of people, to make sure they're consistent with their grading, like to grade everybody all at once, and so that's why we wait for the due date, so that way we can make sure that we're not like, you know, because sometimes, and I find myself doing this, if I grade somebody and then like 2 days later I grade somebody else, it's like, wait, how many points did it take? What did I? So just to be consistent, we just like to do it all at once.
Yeah.
Makes sense.
Yep.
Any other questions?
Nope. Not yet. Probably in an
Not
hour.
yet. Okay. Well, if you do have questions, you can email me. I won't be, let's see. So I actually tutor high school students on the side as well. So in an hour, that's what I'll be doing. So I won't be checking my Grantham email, but anything you email me for sure, I'll be looking at on Monday, so I can respond to those. And then if you signed up for Remind, that goes to my phone. My email doesn't. So if you do send me questions on Remind, that I'll have with me, and then I'm much more quicker than email if you send me things in Remind. So that's a good way to, or if you do Google Hangouts, that's also my phone. So that one I'm quicker than email on. So, all right. So if you guys don't have any more questions, you know how to contact me. Your discussion, the discussion post, the main post is due tonight. So I know a lot of people have already done those already. So if you have, cool. Lots of posts to read. I posted something like about an hour ago, another suggestion that from another student who had talked about like how they were successful and stuff like that. So reading that would be probably helpful for a lot of people. And yeah, so that's it. Hopefully you guys have a safe Sunday. I don't know where you guys are, but here in Kansas City, we are forecasted to get 5 to 7 inches of snow, and we've already got about 2. So and they have not plowed my street. So for me, I have to go out for my tutoring. I have to drive out. So I'm hoping that I'm going to be safe. But I hope that wherever you guys are, Brad's got a nice, sunny, green area.
I'm in northern Maine, so I got plenty of snow up here.
So
I'm in just such terrible weather here in Phoenix.
Oh, nice.
Yeah, so we're all wishing we were Brad right now.
Okay,
so,
everybody have a good day.
Yes, all of you guys. And I will talk to you guys all later. Communications will go out with when I have the next session scheduled for week 2 and all that good stuff. So you guys have a great day. Bye.